Good evening, everyone. This is Meldita, and I'm back after about a month. Miss you all, guys. So our topic for today is kidney. When kidney is healthy. So where do you find your kidneys? They are actually behind your peritoneum, inside your abdominal cavity. The heart supplies 20% of the cardiac output to the kidneys, and each kidney has 400,000 to 1.2 million nephrons. So one kidney cell is called a nephron. That is the functional unit of a kidney. So we have a drawing here which I made. We have the right and the left kidney here. The right is actually lower because of the liver. And we have this abdominal aorta, the red one. And it branches to renal artery, clean blood supply. And dirty stuff coming from the kidney will go back to the renal vein, to this inferior vena cava, back to the heart. So when blood is filtered and everything, urine is processed, it goes to the ureter, the green ones, and to the urinary bladder, the reservoir, temporarily, and goes out of the blood and goes out of our body to the urethra. There are many functions of our kidneys. When you talk about kidneys, we talk about urine. So the kidneys, they make and excrete urine. So the urine is actually the product of your filtration, reabsorption, secretion, and excretion. The kidneys act as blood filters, so they remove waste material, toxins, and extra water with the urine. Endocrine functions, they regulate the fluid and electrolyte balances, the activation of the RAS, the renin-angiotensin aldosterone system, and also the red blood cell formation from erythropoietin produced by the kidneys. Vitamin D3. Vitamin D3 is needed for bone mineralization and also the maintenance of acid-base balance by the kidneys, reabsorbing bicarb and excreting hydrogen ions. So nephron, that is one kidney cell. There are two parts of our nephron in here, which is the renal corpuscle and the tubular system here. So this is the main filter of the kidneys. So we say that the blood supply for the kidney is coming from the abdominal aorta to the renal artery. The last part that it reaches, the clean blood, is the interlobular artery. And now here's the highlight. So we have the afferent arteriole, which is bigger. And the efferent is actually smaller in caliber. The ball in here is called this glomerulus inside the Bowman's capsule. And it is made up of many capillaries. And this is now the filter. Okay. And that filter here, I'll show you the cross section of the filter here. That is the capillary. And we have here, surrounded by the capillary, we have the basement membrane, glomerular basement membrane, and the podocytes. Here, we go closer here. So the capillaries here, the wall of the capillary, we have fenestrae or holes. Next to that is the glomerular basement membrane. And that is the second layer of filtration. And the third part is the podocyte. That is the foot, or this is the, these are the pedicels or the foot processes. And this is the podocyte. And they surround each capillary. And actually, they are the third layer of filtration. So, and they are made up of protein and everything. So, if the blood reaches the ball of capillaries in here, the red blood cell and the protein are too big to cross the filtration barrier or membrane. So they go to the efferent, to the peritubular veins, and support whatever they deliver their oxygenated blood. From the top, then it goes down. And they are now called this linear or, vertical. These are called the vasa recta. And they go back, they are being used up now. So to the vein, interlobular vein, back again to the right side of the heart, going to the lungs. Okay, so that is the fate of this protein and red blood cell. But how about the filtrate? So the filtrate here, there's so many of them. The filtrates are easy to pass. There are smaller molecules. We have here glucose, amino acids, sodium, chlorine, bicarb, phosphate, water, urea, ammonium, creatinine, all these things. They go in here, and now they reach the proximal convoluted tubule here. So there are three processes involved in here. Reabsorption. We have reabsorption in here. Reabsorption meaning it will reabsorption is the ultrafiltrate going to the peritubial capillary. Okay, so in here, when you say reabsorption, these are the following elements to be reabsorbed here. Glucose, we have amino acids, sodium, chlorine, bicarb, water, and phosphate. So they are absorbed here. And there is secretion happening in here. The secretion is hydrogen and ammonia. And the excretion now is the ammonium. So this is less diffusible to the membrane inside. Okay, then here comes the loop of Henle, the bigger one to the skinny one, and then here, that is the loop of Henle. So in the loop of Henle, we have the descending and reabsorption happens here, and water is reabsorbed. But going now to the ascending loop of Henle, they do this ascending does not reabsorb water, but it will reabsorb sodium, chlorine, potassium, magnesium, and calcium. Then going to the distal convoluted tubule here, we have reabsorption of sodium, chlorine, calcium, and water. And proceeding to the collective tubule here, we have again reabsorption. The cortical level reabsorbs sodium. And the secretion here, the cortical side secretes hydrogen, and the cortical B will secrete bicarb. They will secrete bicarb. But excretion here is, on the cortical side, is potassium. And then the medullary, okay. The cortical side is potassium. Medullary is water. And deep medullary is called urine. Okay, so going back here to this filtration here, why is so important that we have to be, very meticulous when it comes to, why do you think this is really a filter? What do you think is going on in here? Okay, we talked earlier that this is an afferent arteriole. The nature here is actually, it's dilated. That is the normal status of this afferent arteriole. So this is dilated, and the afferent is normally constricted. And these two, dilated, constriction, increases the hydrostatic pressure. When do you think the hydrostatic pressure will be affected and drop? It will drop the hydrostatic pressure if the blood pressure is low, the cardiac output is low, or if this is dilated and this is constricted. So they will drop. So the thing to make them increase is leave this dilated, keep this constricted, and you have a good filtration here. A good hydrostatic pressure is a good filtration driving force in here. And here we have the juxtaglomerular apparatus here. So I moved this distal convoluted tubule here because the first drawing I did not put it. So here, I put it here. So this juxta is shared by three structures here. We have the afferent wall, we have the extraglomerular cells, and we have the convoluted macula densa. So it is from this wall of the afferent that the renin comes in case there's a problem with pressure and they try to constrict the afferent. Then renin is produced by the kidney, and that will start the induction of the angiotensin